Hello everybody, here's a second example using Cartesian vector notation. Note that I only have two forces acting on this bolt here, um, and I'm showing also something a little different. I have this notation here. So really what this is telling us that this is 12, this is 5, this is 13. I could solve for theta. So if I wanted to solve for theta here, I could use sine, cosine, or tangent on any of these. So if I used tangent theta, that would be equal to the opposite over my adjacent. So theta then would be equal to the arctangent of 12 over 5. So if I throw that into my calculator, I get 67.3, or 67, we'll call it 67.4 degrees. So let's look at this vector f2 real quick and just show something. We can say that f2 in the x, let's just look at the x direction. Now if we were using the angle, we could say 26 kilonewtons times the cosine of 67.4 degrees. So if you plug that into your calculator, you're going to get 10 kilonewtons. Now I could also do it in a different way. I could say 26 kilonewtons, and I can use this triangle to solve for my x component as well. Since x is here, and that's 5, and then I've got my hypotenuse is 13, so I could just say 5 over 13. Let's just plug that in the calculator and make sure I made it since I did it right. And yeah, that also equals 10 kilonewtons. So that saves you a step really of solving for your angle, and it's real easy to say my x direction is in 5 and my unit for 12 would be in the y direction. So let's go ahead and solve this using vector notation. So I've got force 1 is equal to negative 30 kilonewtons, because it's going in the negative x direction. Now here I said negative 30. Now I could use either way I want. I have this angle here that's 30 degrees, so I could say sine, or I could say cosine of 60. Either one works perfectly. So I'm going to go ahead and say sine of 30 degrees. That's in my I direction. My I direction, not my y. I. If you note that the y direction, or the j, is also going negative, so I'm going to say negative 30 kilonewtons times, now this would be cosine of 30. So there's my vector notation for F1. F2, well, let's go ahead and put our answers here. I got negative 15 kilonewtons. This would all be in kilonewtons. Negative 15 kilonewtons I minus 25.98 J kilonewtons, and that's force 1. Force 2 then is going to be 26 kilonewtons. Now, this is also negative because we're in the x. We've already done this one, so it's 5 over 13. I, you could also say cosine of 67.4. Plus, now my y component of 26 kilonewtons times 12 over 13. Or you could say the sine of 67.4 degrees as well would be the same as 12 over 13. And that's all in kilonewtons. So computing this out, I got negative 10 kilonewtons plus 24 kilonewtons. and that's in the I and the J. Now note I put kilonewtons on the outside and then I put kilonewtons here. Either way works. So to find my magnitude or my resultant force of the two, I could say that Fx first. So my forces in the x, summing my forces in the x, I got negative 15 kilonewtons minus 10 kilonewtons is equal to negative 25 kilonewtons. That's in my x direction. If I sum my forces in the y, I got negative 25.98 kilonewtons plus 24 kilonewtons. And that came out to be a very small number. We'll just call it 2 kilonewtons. So if I was to draw that, that would be very small here, somewhere like this, with this being theta. Okay, so my x again was 25 and my y here would be 2. So solving, be negative 25 squared plus 2 squared, square root of that. My force resultant then would be 25.1 kilonewtons. And then to solve for theta, we could say that the tangent of theta is equal to the opposite over the adjacent. So theta is equal to the arc tangent of 2 over 25. Plugging that into my calculator, I get 4.57 degrees. Now that's this angle here, so we would say that's 4.57 degrees, and that would actually be positive, okay, positive 4.57, but it would be counterclockwise from the negative x-axis. So if you have any questions on this, please let me know. We're going to be moving on to 2.5 and 2.6 on our next video. Thank you.